Okay, today's topic is the transformation of tangent and cotangent functions. We'll do tangent first. And in order to do this correctly, we should have a tangent parent graph available. And it looks like this. And you have a tangent parent graph, and there are asymptotes at -90 and 90. Now, because of that, the period of the tangent function is 180 degrees, or pi radians. And we had figured changes in parent function for sine and cosine by this formula. And it was 360 degrees over b. Well, because of this, the tangent period is only 180 degrees versus 360. You find the change in period by 180 over b, or pi over b. Now that's true for tangent and cotangent. It's not true for secant and cosecant. We'll deal with that tomorrow. But anytime you're dealing with a tangent or a cotangent graph, you have to keep that in mind. All right, so with that in mind, we'll take a look at problem number 5, which is y is equal to 3 tan x over 4. Now there are two changes here. We've got an amplitude change and a period change. And another thing I'm going to put up here on the parent graph is this is the point 45 degrees 1, and that's the point -45 degrees -1. And we're going to keep track of those points on our graphs because of the amplitude changes. That's what's going to show us our amplitude changes, is the stretching of that point. Okay, so the amplitude is 3, and we're going to figure the period by using this formula. And that is, we're going to I should write this down. We'll graph this from -360 to 720. All right, so the period we're going to find by taking 180 degrees and dividing that by, this is actually 1/4. Now, if you divide 180 by 1/4, you get 720 degrees. All right, so the period of this will be 720 degrees. It's not going to be 180 degrees. All right, and we're also going to write down half cycles for this, which is going to be 360 degrees, and quarter cycles, which is 180 degrees. Now, the reason these are important is, like if you look at back up here at the tangent graph, this is a full cycle. Half cycle is from inflection point to asymptote. Quarter cycle is from inflection point to this point that we're going to use, we're going to graph. Okay, so we need all of this information. All right, so let's put our axes, set up our axes from -360 to 720. And we're going to have tick marks at 180, quarter cycles. And that's what we need. All right. Now the critical point of the tangent is this point right here. The origin, 0, 0. And there's no shift here, so we're going to still have 0, 0. Now, if you look at the tangent function on the parent graph, and it's very important to have a tangent graph available while you're looking at it. You know how you're going to do this. Between inflection point and asymptote, that's a half cycle. Now, our half cycle is 360 degrees, so that would be right here. And we should label our asymptote with a vertical line. X is equal to 360 degrees. Okay. Well, we're going to go this way too. Another 360 degrees. Okay, so then, well, that's good. All right, no problem there. All right, so between inflection point and asymptote, we have this portion of the graph. All right, so the graph is going to, basically this graph, and we can even sketch it in first. It's going to do this. Okay, way because it's going to have to look like the tangent function. All right, at the quarter cycle on this graph, we're at the position of 1. On the quarter cycle here, this fat graph is going to be at 3. So probably best to draw the graph in and then put this point on there. That point is going to be quarter cycle, 180 degrees, 3. And over here, quarter cycle that way, 180 degrees, -3. All right, what happens from 360 to 720? Well, this thing is going to keep repeating itself. So if you look at the asymptote, on the right side of the asymptote, we have the graph going down like this. And between this asymptote and here is 360 degrees. So we're going to have this portion of the graph over that interval. And we're going to have another point right here that's a quarter cycle away from that asymptote. So if I add 360 plus 180, that's 540. And that will be at -3. All right, and that's the graph. All right, let's check by grapher. Let's slide up a bit. No, I'm going to keep that parent graph there. So now we'll slide up a bit. Okay. 3 tan x over 4. Window from -360 to 720. And, you know, we want to make our, if that's 3, actually, I should have put a scale in here. That's maybe, we should draw in the tick marks at 1. All right, so let's go. We want the tick marks on the x-axis at 180. So let's go a little bit further than -5 to 5, maybe -8 to 8. And let's see how it looks. All right, now again, every time we've done a trigonometric graph, you should end up, when you check by grapher, with the same thing that you put on your paper. Okay. All right, next problem is number 11. Although, we're not going to do number 11 exactly how it appears in the book. The book appears y is equal to tan of x minus pi. I'm going to change this to x minus pi over 2. This is a change from the book. Okay, and the window for this one is going to be from -pi to +pi. All right, there is no period change here because there's no difference there. So the period for this graph is going to be pi. Half a period is pi over 2, and a quarter period is pi over 4. All right. There is a shift, and I'll put the shift over here because I'm going to graph here when I'm not from. All right, you find the shift the same way we did the other ones. X minus pi over 2 is equal to 0. X is equal to pi over 2. So we have to shift the critical point, pi over 2 units, to the right. All right, now we're going to graph -pi to pi, and we're going to need tick marks. So it's every pi over 4. Okay. All right, pi over 2, which is 2 tick marks, that's where this critical point's going to be. Okay. Now, if I look back up at the parent graph, let's slide that back down. And you can't base this on the actual numbers of these things. It's half cycle or full cycle, that type of stuff. So between this inflection point and that asymptote is a half cycle. So And on the other side as well, between that inflection point and that asymptote, that's a half cycle. All right, so we're going to, that's why it's important to have this information available for you over here. Half cycle is pi over 2, that's 2 tick marks. So I'm going to go 2 tick marks. I have an asymptote. That's at pi. Now if I go 2 tick marks this way, I've got another asymptote. That's at x is equal to 0. Now 2 tick marks to the left of that, I have an inflection point. This inflection point was at pi over 2, 0. I should have written that in. This one's going to be at negative pi over 2, 0. And 2 tick marks further, I have another asymptote. Okay, just a review on that. You find the, for the tangent cotangent type graphs, the first thing you do is figure out what the period is. In this case, it didn't change. Then you figure the shift. Now for the tangent graph, the shift is the critical point. The critical point, oops, I was off screen up there on the parent graph. The critical point on the parent graph, okay. That gets placed. Then from that critical point, you go half cycle in either direction to get asymptotes. And you just keep in that pattern. Half cycle, asymptote, half cycle, critical point, half cycle, asymptote. That's for all tangent graphs. Okay, so the tangent graph has this shape. So we'll draw the tangent graph in like that. And again, it's better to just draw the graph in and then put these other points on. All right, now going back to the tangent graph. (45.1) is a point that's on the tangent graph. Now that would be, in radians, it would be pi over 4. But the important point is it's halfway between the inflection point and the asymptote. That's a quarter cycle. All right. Well, that important point here is going to be halfway between the inflection point and the asymptote. That's pi over 4. Now, from pi over 2, if I add pi over 4, that's 3 pi over 4. And that's at 1 because there was no amplitude change here. If I go this way, pi over 2 minus pi over 4, that's 1 pi over 4, and I'm at negative 1. Negative pi over 2 adding pi over 4, that is negative pi over 4, and this is a positive 1. Negative pi over 2. Subtracting pi over 4, that's negative 3 pi over 4, negative 1. Okay, let's check by grapher. Okay, so we have tan. Let's clear that. X minus pi over 4. And our window is negative pi to positive pi with tick marks at pi over 4. And I don't think we need to go negative 8 to 8 this time, maybe negative 5 to 5. Now I didn't change the mode, which is going to be important. And then we graph. And that is not right. Obviously, what did I do wrong here? Oh, x minus pi over 4, x minus pi over 2. I got ahead of myself. That's your homework problem. You go back and review that and see what it actually looks like. Okay. That's more like it. Now, notice in this time that the graph doesn't appear exactly like I have it here. That's because I've got this stretched out a bit. Now, if I say this tick mark is 1, then really our graph up here, the top of the window would be at 2. Here, let's change that to make it look better. Because if it doesn't look the same, you do want to change it, So let's go from negative 2 to 2. Make it look good. Make them look alike. They should look alike. And that way you can have confidence in what you did is actually correct. And it takes practice, a little time to do this. Okay. And then put the trace on. Let's try 3 pi over 4, which should be at 1. There it is. Let's try negative pi over 4. That should be at 1. Okay. It all works out. Okay, so I was going to do cotangent today, but this took a little longer than I expected, so we're just going to stick with tangent today. So you will have 2 problems. Now, I'm not sure if this will be a 2-day assignment or not. Sometimes they are, sometimes they aren't. You have to check back on the dashboard tomorrow to see. Alright, so this is section 5.6 in the book, which is on page 567. Alright, you've got number 6, and the window on that one, it's a degree problem. Negative 360 to 720. It's very similar to the example that we just did. And then you have number 12. And that will be a radian problem, and you'll go from negative pi to, well, let's not go negative pi to pi. Let's change this to a little bit. Let's go negative 3 pi over 4 to 3 pi over 4. Or, pardon me, 5 pi over 4. Okay. And tomorrow we'll do cotangent, or the next day.